Hello ladies and gentlemen, welcome back from your break. My name is Christian Hallm and this is my good friend
Mario Trenado.
And we would like to introduce you to Sonny, the 21st century gardening solution.
Alright, so why robotics? And in the 21st century, almost everything we did had to do with technology. We wanted a more modern approach with help on maintaining the garden. Robotics can assist and be like time. They won't consume much time. They won't, you can invest in it and though it does cost a lot of money to maybe make it and get it over time. You don't have to pay it like you would, an actual person. Yeah, and it saves time, money. It's a great, 21st century solution, and you can make robots go, anywhere where no human can go, so anywhere dangerous.
The history of robotics. Robotics is way older than anyone would think. The first known source of robotics was in 270 BC by an ancient Greek engineer named Chrysippus. He made force pumps and water clocks with removable figures. The only picture I could really find of him was in his workshop, and it's not the greatest picture. I'm sorry about that.
STEM education. What is STEM? The STEM approach to education is designed to revolutionize the teaching of mathematics and science by incorporating technology and engineering. STEM is using mathematics, science, and engineering in an idea, in this case, robotics. NASA is a big supporter of STEM education, and STEM skills can be used to integrate gardening and robotics.
Other uses of robotics in gardens. The tomato picker. Nicholas C., who works in the MIT robotics lab, created a small robot with a mechanical arm that can actually go and pick tomatoes. I mean, this is a great reference to us because both of us are trying to incorporate robotics and gardening together. What's the point of having a robot in the garden? Well, while working with the maintenance crew for our 8 weeks, we noticed that the paths that right next to the gravel always had gravel on it when there wasn't supposed to be gravel. That showed two big problems. First, it didn't look that great because when you're walking, you don't want to be stepping on gravel all the time. And second, it's also a big safety issue because if you're running through the garden, even though you're not supposed to, you might slip and fall, or if you have crutches, you might accidentally slip, which is a really big deal. You don't want anyone to slip.
All right. So the materials we used were Tetrix robotic kit, Tetrix resource kit, Mindstorm microcontroller, wireless ties, 7/8 inch diameter dowel rod. So these are the codes that we used for the robot. These are the pragma codes. So all it does is it tells it, the robot is, there's a motor here, a motor there, and as you can see, motor D, E, F, G. It also tells it where the light sensor is and everything. Down here is like the body of it. The way it works is it's actually really simple. It says, we use light sensor. If the light is actually less than 35, then it'll do this, which D is at 10% power, E is at 10, and F is at 100. And if it's greater than, it'll do this. So in this case, we made motor E 0 because what it's supposed to do is it's actually supposed to go on its own and follow a black line. And when it's on the black line, it actually follows this. The light is reflected off, and there's actually a difference in the light that's reflected off from the black tape than on the lighter surface. So when it gets off the tape, it'll be greater than 35. So it'll follow this, and only one wheel will be running. So it'll turn to get back onto the tape and follow this again. and start moving forward onto the tape again and following it.
Okay, so before we did anything, we sat down with big post-it notes and grabbed 2 Sharpies and we drew out what we wanted to see on a robot. Both me and Mario were thinking the same thing of a rectangular shape with 4 wheels on the outer and a brush in the middle. And if you see the side view, we also did the long, let me juice this. We did a long bar to connect the 2 wheels, and we had a long bar, kind of like a spine, to hold the NXT brake. And we had a little bar in front for support, just in case it fell over. So, after a couple weeks of building, our first design was finished. This took us a long time, and it was really hard to build. As you can see, we pretty much kept to our design where we had the 2 wheels on the side, we had the one in the back, and we had the sport. We did change the length of this because we needed more room for our brush, which we would attach later on. And I actually have a video to show you guys of our first attempt to run this thing. So as you can see, the robot didn't really work there. It was supposed to follow the black line, which represents the side of the path with the gravel on it, so it can sweep the gravel back into its spot. But if there was volume, you can hear the robot was shaking vigorously, so it actually threw itself off the line. Now, we did program it to go back onto the line, but if it kept shaking so much, it would just keep throwing itself on the line, so we had to go back to the drawing board.
Alright, this is the second structure. All we did was we changed the wheel because we found out what was actually making it to really shake and throw it off was the fact that the wheels were on the outside, so they were usually here, and we put it here in the middle. We just put them together, and what that does is it puts the weight down on the wheel. It puts all the weight down on it, and that actually stopped the shaking. And then, as you can see, this is also the brush. We had to make it ourselves because we couldn't really find a brush that could really fit. And then those are all the battery, motors, all the the wires and stuff, and our little passenger there.
Mary.
And then this is the second trial. So it worked a lot better that time. It followed the line, and in this case we actually made it stop so it wouldn't actually turn or anything, but at the end it stopped and it actually worked a lot better. And as for the wheel, it did end up working. It didn't shake too much, so it didn't throw itself off. So a special thanks to our mentors, Sean, Leo, and Cindy, our instructors, Ben, Murphy, and Shelley, and everyone else, all our classmates and donors.
So we were going to show you this video of it actually moving on itself, but instead we're going to have some fun with it and we're actually going to show you firsthand.
Alright, so here we're just using the control. Usually we do have the brush on, but it is pretty loud and obnoxious, and we don't want it to fall off or anything. And normally, like I said, it would be going on its own, but in this case we don't have it because of the lighting, and we actually did have to change and read the light readings and change it multiple times. And if we actually use it right now, we probably have to change it a couple times. You want to hold it up so show the sensor and stuff?
Sure.
So the sensor should be on the bottom right there, and it was originally supposed to be in the middle, but we had trouble with the wire not being long enough, and actually the brush would hit the sensor. And as you can see, that's also the brush in the very middle, homemade. And then turn around the NXT brick.
I don't want to drop.
Yeah, and that's the NXT brick, which is basically where we transfer the codes to, and that's where everything goes. That's how it pretty much operates. I'm gonna run it down the aisle.
All right. Better run it down the aisle so everyone can see firsthand. No showing.
We did have a little trouble though with the turning. Because whenever it turns, it actually slides a bit. So that's probably something that we'd have to fix. I'd go up that aisle, but I actually can't see.
So are there any questions?
A quick suggestion, right? When you have the robot, you need to consider the type of materials that you're using. Most of the time, you can be using oxide metals or actually transitional metals, right? The type of material can be essential when you place a roll and exposed to many, because this is going to be for like a gardening idea, right? So you need to consider water and the oxidation states of the transitional metals, meaning they're going to be wouldn't degrade, right? So pretty much like a suggestion, right, would be develop a mechanism in which they would sort of auto-protect itself when the weather conditions changes. When it encounters obstacles, maybe develop some sort of like wind turbine so you can hover over the obstacle, right? And also if your circuits that you're using, if you're using silicon oxide or crystal-based circuits, maybe consider some of the better semiconductors for the better development of having the hardware work better.
Well, this is only a prototype, so we haven't really gotten it. So, between time and what we can get our hands on, this is pretty much the best we can do. Which I think it turned out pretty good to be a prototype. Any other questions?
So this works by using light sensors to see if there's gravel that needs to be brushed off, or how do what light sensors do?
The light sensor for now is to detect the line. So yes, like I said, it like the difference in light from the tape, because it's really dark, and a lighter surface, it'll detect, if it goes off the tape, it'll detect, the light would be greater or less than, and then if it is, then it'll turn back onto the line. But as for detecting the gravel, we
Constantly brushing.
yeah,